a logic question and also a few reverse Polish notation questions from paper 1 A level. So the question we've got is about carrots and onions. So this is just a logic question. There's been one or two of these sort of things. One about who murdered somebody, and this one about carrots and onions. So one of the box contains carrots and onions. One contains just onions. One contains just carrots. So just for fun, we've drawn the boxes and they've been labelled, but we know they're all labelled incorrectly. So then it wants us to describe how we can work out what each box actually contains if we just take one vegetable out of one box. So we know they're all labelled incorrectly. So if we go for this box, which has got both in, so we can take a veg from the carrots and onions box, and if it's a carrot, then the onions box is carrots and onions, and the carrots box is onions, and our box, the carrots and onions box, is carrots. So all it's doing is asking you to think about this logically in a logical deductive sort of process. So if we take something out of carrots and onions, if it's a carrot, then that must be the carrots box because it's labeled incorrectly, and that means the carrots box must be onions and the onions box must be carrots and onions. And if it's an onion, then that's the onions box, and the onions box must be carrots and onions, and the carrots box must be onions. So there's only one way of sorting it out and thinking about that. But strange kind of questions, but they do put those in paper 1 occasionally. Okay, so we've got a couple of reverse Polish notation questions, which was tagged on to the same kind of question. So again, we need to deduct something or deduce something here, I guess. So this one was 2 marks, and that was just 1. So how would we the infix expression 5 minus 3 be represented in reverse Polish? Well, reverse Polish has the operator after the numbers that it applies to, so 5, 3 minus would be reverse Polish for that one. This one, slightly more tricky to think about this one because obviously we want to do that first because it's times and times comes before adding. So we obviously want to do 4 2 times, but our 3 is still there. We haven't lost it. So when we've done that, we want to add. So we do 4 2 times, and the result of that we do 3 add, and then we've got this 1 that we want to take away. So 3 4 2 times plus 1 minus for our 2 marks on that one. So that one just takes a bit more thinking about, but if we try to remember the order we want to do them in, and I just wrote those down first with the times and then thought about what to do with the 3 afterwards, but you might just think, oh well, I can see that straight away. So there's another one here, just explain why reverse Polish notation is sometimes used. So this is explained, so it's trying to show you understanding. So we could say it's simpler for a computer to evaluate, and we don't, because of the way the computer works and the way it works with the stack, then we can evaluate the expression in one go rather than backtracking, etc. while we're doing that. So as a result of that, we can say we do not need brackets to show order, and we could say no need to backtrack when evaluating. So there's three answers there we could use. We only need two of them. So simpler for a computer to evaluate, we're going to get a mark for that one. I do not need brackets to show the order. I suppose we could say the order of the calculation. But even if we didn't, I think we'd still get that. And then no need to backtrack when evaluating. That's another one we get there as well. So if you only remember a couple of them, 2 or 3 of those, these are probably the 3 easiest ones to remember because they're sort of related. So as long as we know it's simpler for a computer to evaluate, and that's because of it's using the stack and doing the calculation in the order that it comes across it, and so you don't need brackets, and so because of the first one you don't need to backtrack. So there's just a couple of questions there on logic and reverse Polish.